Here, what?
10-minute breaks?
You need break?
No, as you like, as you wish.
No problem. I can give you break, but after 2 slides, especially 2 slides, or not more. Okay.
No, no problem. Okay.
We have here in thermodynamics remaining just a Carnot cycle this slide and 2 questions related for Carnot cycle. Take break and we're going to start for another topic. Okay.
Okay.
Carnot cycle here, it is consists of 4 processes. This 4 processes is 1 to 2 is isothermal process, as you see here. 2 to 3 is adiabatic process. 3 to 4 isothermal again. 4 to 1 is adiabatic. It means we have 2 process isothermal, 2 process adiabatic. Be aware, Carnot cycle is the ideal cycle. Okay, ideal cycle. It means the highest efficiency for cycle ever, it is Carnot cycle. There is no cycle have efficiency higher than this Carnot cycle. Okay, any cycle compared to Carnot should be less for efficiency. This is the ideal one. Consists of 2 isothermal process, 2 isothermal process. This one isothermal, this one isothermal. Okay, for first one is isothermal expansion of the gas at the hot temperature side. And the other one for 3 to 4, this one is isothermal, but isothermal compression. Isothermal what? Isothermal compression of the gas at the cold side. This cold side here, this hot side here, this TH, this T low. Okay, T hot, T cold. Other 2 process is adiabatic process. For this one is isentropic because it is reversible adiabatic. Reversible adiabatic, it means isentropic, and isentropic, it means S equal constant. This isentropic expansion from 2 to 3, and this from 4 to 1 isentropic compression. The famous equation here, as after simplification, the initial equation efficiency equal work divided by Q heat, output by input. This general equation for efficiency, output by input, work by Q added. And especially for Carnot, we can substitute for the heat and work by temperature. By what? By temperature. Work is QH minus QC, which is hot minus cold. QH is can represented by TH, and QC you can present it by TC. So at the end, we will found Carnot cycle is equal to efficiency of Carnot cycle TH minus TC divided by TH. TH minus TC divided by TH. Again, efficiency of Carnot cycle. This is important equations because it is very simple and it's not coming in the exam. If the question coming numerically for Carnot cycle, this equation not coming, okay? And sometimes I ask you one question related for Carnot cycle, how to increase the efficiency, and we decide to select decrease the TC, decrease TC. You remember?
Yes.
Yeah. So the efficiency for the Carnot cycle TH minus TC divided by TH, okay? Also, the other way for the problem numerical is given 2 temperature, 1 hot side, 1 cold side, and required efficiency, and keep it you without any equation given, okay? So this important equation at all, okay? Going to some problems, some theoretical questions, easy. In a Carnot cycle, heat is transferred at
Constant pressure. Oh, constant temperature.
C.
Again?
C.
Constant temperature.
T, constant temperature. Which of the following statement is incorrect?
One. All
reversible cycles have the same efficiency.
Which one?
Number 1.
First one. Number 1.
All reversible cycle has the same efficiency. Yes, it's not all the have the same efficiency. Is correct.
Yeah, the Carnot is the highest one.
but other is correct. Okay. Now we finish this part. Yeah. Okay, started. Heat transfer part. First, what is different between thermodynamic and heat transfer? Why we study heat transfer? Thermodynamic topic, it's not enough. We will see last session is first law of thermodynamics is not enough. So we study second law of thermodynamics to complete the story for thermodynamics, correct?
Yes.
Also for heat transfer, it is not enough the topic thermodynamics. What is the main issue for studying heat transfer?
To know the property of material.
Material.
For the
I give you small
heat
thing
ventilation.
to maybe we going to the way for the answer. One variable, there's a reason to study heat transfer.
So just now you started, I think.
Again?
Just now you started the class after break.
yes, yes.
I didn't hear you.
I got, sir. I answered already.
Okay. What is this parameter?
Sorry.
What is this parameter? Only one one thing, one main issue to study heat transfer.
Thermal conductivity or thermal? Is it the medium?
It's a rate of heat transfer.
Time?
Yes.
Time consuming of the transfer.
This is the only reason to study heat transfer. Actually, heat, we can calculate it and cover by thermodynamics equations. Correct? First law?
Yeah.
But rate of this heat, we can't. If you have two cups, one of cup like the ceramic cup, what I take a tea for that today. But if I bring another one, but carton, both is going to be cold and make equilibrium with the surrounding, correct? But the difference is what? The difference is time. The difference is time, correct?
Yes. Yeah.
One is take, for example, 10 minutes, but other one maybe take 15 minutes, 20 minutes, correct? So time is one of the main factors, and we need to know what is the effect for this factor. Actually, this factor of the time is depend on another parameters, another factors. But what is the main issue to study heat transfer? Time. So this time, what is it depends of what? This other thing. It depends on material, thermal conductivity, depends on the thickness of material, it depends on the surface tension, large cup, it's not the same small cup, and so on, correct? So I have another factors, but all affect on what? Time, correct?
Yeah.
Okay, clear? Okay, going to next. Let's do this. What is heat? This is previously heat energy in the process of being transferred from an object to another due to difference in temperature. I think we discussed last session.
Yes.
We have several different types of energy transfer process going on here. What is this?
Convection.
Conduction, convection, radiation.
Conduction, radiation.
Yeah. Convection, conduction, radiation. Okay. This is the different modes of heat transfer. Different mode of heat transfer. Actually, when we study application, what is the main or the type or the mode of heat transfer those application? We check and we is by conduction, is by convection, is by radiation. But actually, we will answer conduction, convection, radiation, which is mean dominant, because mostly for all application, the three is happen, three modes happen, but two all the time normally is happen by a small amount, and the one is dominant. Sometimes is due to its big effect, and one is small, third one is small. Sometimes is three, it is dominant in some application. Okay, but the famous is one is dominant and two is latent. Clear? I tell you something for that. For example, this example, he brings this photo as a transfer of heat by conduction and so on. But actually, if you focus more, actually the three modes happen here for this one. So where is this? By conduction, according to the heat transferred by this stick, molecule by molecule, molecule by molecule, molecule by molecule, according to the contact between this molecule, contact between molecule and the contact with another. So the conduction need contact. Conduction need what? Contact. Need contact by for conduction. So the heat is transferred from the flame candle of the candle to your hand by conduction according to this stick. But actually, if you focus more, you see other effect. Maybe it is not a big effect. What is this effect? Convection. Here, for this surrounding between hand and candle, we have air. So the air here is heated by flame, and here is air here is cold. So the air here cold and the air here is hot. Now we have a little different densities. You can this one going to move in this way and this one going to move another way. So make a circulations, and after sometimes you feel with the heating also coming from the air itself. So this by convection, and also the flame itself. Your hand it is directly phased with the flame. So some radiation coming from the flame itself. So this is by radiation. But according to this study for the figure, we will focus for the main one coming for the heat, which is coming by this stick by conduction. Clear?
Yes.
Okay. Concept of heat conductivity, how efficiently substance transfer heat between molecules. This is the conductivity of the material. This is what you said. Thermal conductivity for this material is good. Thermal conductivity of this material is not good. This is bad, and so on. Which is good, which is better for conduction, which have a material good conductivity. Yeah. What conductivity? Efficiency of substance, how to transfer heat between molecules. Okay. And it depends on the structure bonded together. And this one, when you're going to be strong bonded, it means it's high conductivity, because mainly conduction, it is happening between contact between molecule and another. So when this molecule is going to be strongly bonded, so is high conductivity. And when this the structure between bonded, it is going to be less and weak, we're going to low conductivity. So gradually going from the solid to liquid to gas, which is gas is the low conductive material. Okay.
Yes.
Here, like for example, silver is 4 to 7 heat conductivity, and for air, for example, 0.023.
0.023.
Yes, for in between for water, something like this, 0.6 in between. Okay.
Yes.
Heat capacity. Focus with me, please, for this concept. The previous one is conductivity. Conductivity is a property for the material. We have another property for the material, which is heat capacity or specific heat capacity. What's different? Conductivity it depends on the structure of the material and what is the bond, the shape of the bond here. What is the type of the bond? Is it strong or weak? Okay, it depends on the material itself. Okay, high conductivity, it means the efficiency of heat transfer is high. Efficiency of heat transfer is high. But not talk about for the rate of heat transfer. The rate of heat transfer. The high conductive material not by default not means it is going to heat it quickly. No, it's totally different between this good material for heat is good conductive and the response of heat transfer. What's the meaning of that? Response of heat transfer controlled by another factor is called heat capacity. Heat capacity is amount of heat energy absorbed by a substance to the temperature rise. And the definition of specific heat capacity, the amount of heat required to increase 1 unit of mass, 1 degree C. 1 unit of mass, 1 degree C. And for low specific heat, for material have low specific heat, it is a material heat or cool quickly. Low specific heat and cool quickly. High specific heat, low and heat and cool slowly. So I have two material to conduct high conductivity. The both material is high conductivity. Both material high conductivity. Which one is going to heat or cool quickly? It is not depend which is higher conductivity. No, both actually is higher conductivity. Whatever which one is the first one is higher the second one. But the control of response of heat transfer according to specific heat. So going to in the table and you check the another part which is referred to specific heat and check which have low specific heat. Which one have low specific heat? It is heat quickly or cool quickly. Like I give you example to be clear. For example, aluminum. I will give you example here during this session, but I give you practice example. For example, aluminum. Aluminum. If you make some food in the aluminum, and you make some food in copper, for example. When you heat the copper and when you heat the aluminum, both is high conductivity. I know the copper is higher conductivity than the aluminum, but both is good conductive material. But copper, it is heat and cool slowly. But aluminum, it is heat and cool quickly. So aluminum is have low specific heat, but copper it is have high specific heat. You understand me? Yeah. So we have another property. It's very important in heat transfer. Not only conductivity, it is specific heat of the material. For example, this water, for example, specific heat is 1. For air, 0.24. For some of the solid like granite is 1.9. Okay. Convection. What is the other type of heat transfer? It's a convection. Convection is the transfer of heat by mass movement. Mass movement, as you see here for this example, mass movement, the air up and water down. For both between water and the air, we have a convection between these two. Convection heat transfer. This one is heated down, so the heat is going up and the cold going down. This movement, okay, it means convection. And also between water and air, water is hot and air is cold, and heat transfer between these two. What is this type? Is convection, transfer of heat by mass movement of a fluid or gas, or in between water and gas and liquid. Same like this one, for example, the reason for convection in atmospheric. Why? Because cooler air going down, warm air going up. This is the same what we talk. This is an important thing to be aware here for. What is latent heat? Latent heat is energy required to change matter from one state to another. Definition is very important, okay? Not coming, maybe it's not coming like this direct, but sometimes it's coming a question answer by understanding this definition, latent heat. Actually, body obtain heat to do one of two things, not both together, one of two things. If body added heat for this body, he takes this heat to make one of things, one of things. What is this? First thing it can do, temperature change. Temperature what? It change. Temperature increase because we add heat, it means temperature increase, not decrease. Or not and, or change phase. Change what? Change phase.
Yes.
So the heat not going to do both the same. Heat, when add heat to fluid, to gas, he do something of two, not both. It change temperature to increase temperature, or it change phase. For example, for the state of water, what happened for the state of water according to the curve here? What happened also? For the state of water, what's the boiling temperature? 100 for regular conditions, okay, at standard condition, because it may be changed according to the pressure change. So before 100 for standard condition of the pressure, before 100, what happened? We add heat till we reach to 100 degrees C. Once you reach to 100 degrees C, whatever you add heat, the temperature not increase.
Yes.
Bubbles happen, everything happen. What is the temperature for the water? 100. After 10 minutes, 100. After 2 hours, 100. After 1 day, and you have in the bottle water and still
The
100.
temperature remains same.
Same, not a change. But what happened in this case, in this
Phase.
condition?
The water will
It changed to phase.
evaporate.
All energy going to this water, take it to change the phase from the water to the vapor. Okay, so the energy going to into one of that ways: increase temperature or changes phase. For example, for this curve, this saturated liquid, saturated vapor, here it increase the temperature till we reach to 100, for example, at standard temperature condition, pressure condition, and going to be 100 to be totally steam. Once you reach to be totally steam, any energy added going to increase temperature again. So the energy required to increase temperature is sensible heat. The energy required to change matter from one state to another, this is what? Latent heat. Clear? Okay. Some examples here. Here, ice, liquid, vapor. What is this process from ice to liquid? Melting. From melting to vapor, evaporation, and total from direct from ice to vapor, sublimation. From vapor to liquid, condensation. From liquid to ice, freezing.
Yes.
And directly from vapor to ice is deposition.
Position.
And this latent heat of fusion from the ice to liquid is mentioned by latent heat of fusion. And the other one here, latent heat of vaporization from liquid to vapor. So the latent heat of sublimation equal to what? Equals the total latent heat. That's it. Direct summation. This one plus this one. But just I need to tell notes or some hint. What is this hint? See, the amount of latent heat during vaporization, it is higher than the amount of heat by fusion, by a huge amount, almost 8 times, something like this. So it is easy to change it from solid to liquid, but it's not easy to change from liquid to vapor. Clear? One question here. The question is clear?
Yes.
Read question. Just I close the door. Read question. Why metal feel colder than wood if they are both at the same temperature? Why?
Thermal capacity.
Yeah, metal is a conductor, but wood is working as insulator. So the metal, what?
It removes the heat of the hand.
Make a heat transfer between the metal itself and hand. So you feel cooler. The heat is transferred. But wood is nothing happened. So you don't feel anything with wood is slightly warmer than metal. Clear? Just describe what happened of the particles, the liquid or gas when heat them. What happened? Mainly, the first thing happened when you heat the liquid or gas, particles spread out and become less dense like this. Correct? Also, before, as per the previous design for the freezer put it up. Why? According to the normal sequence of the refrigeration and the air heat transfer cycle, which is anything going the warmer thing going from bottom to up, and the polar thing going from up to down, and so on, make a circulation. Here is this radiation. The third type. This radiation is the third type of heat transfer. Third type of heat transfer, and this travel in a space. No need for a media to travel for this one. We ask some questions. Radiation travels in
Waves, is it?
Travels in a straight line.
Travels in straight line.
True.
Speed of light.
True.
Radiation can travel through a vacuum.
True.
Radiation required particles to travel.
False.
False. Radiation travels at the speed of light.
False.
False.
No, yes.
Yes.
No problem.
Yes.
Read the question.
Okay, we filled with warm water, which container would have no or less water after 10 minutes. Is it the black one?
Dull black. Dull black.
Dull black.
No.
It is important here to important point here. 4 containers were filled with warm water. It means the source of heat up inside or outside.
Right.
Inside. This is the important thing for you. Now the source of heat inside. The which one container would be the warmest after 10 minutes?
Dull black?
Shiny metal.
No. So it's gonna be dull shiny.
Shiny metal.
Shiny metal, according to it's shiny here.
Shiny
Yes.
metal.
Yes, shiny surface is reflect.
Because black will be absorb more heat.
Yeah, it's anything coming from inside is going. So this one is shiny metal. Other one, the coolest,
Dull black.
dull black, because the dull black body it have
More heat absorber.
yes, best benefit for it.
Umbrella.
Absorb everything and also emit everything. This is dull black.
Black umbrella.
One of the conditions of black body, it's emit everything, but also absorb everything at the same time. Shiny metal, and this according to the reflect heat radiation back to the container, so less is lost. And the dull black container would be the coolest because it is based on the emitting heat radiation. So the next question here talk about for the same 4 containers with the same conditions, but equal distance from heater. So the source of heat is out, correct? The source of heat is outside.
So the
This will be
flow
the
black
opposite
will have the warmest one.
So reverse.
This will be
Dull black and shiny metal.
Is opposite.
shiny
direction.
metal.
Opposite.
Yes, dull black is the warmest after 10 minutes because its surface absorb heat radiation, correct? But
Yes.
the shiny metal coolest because it's poorest for absorption because all is reflected, correct? Why does hot air raise and cold air thing?
Less density.
Correct.
Dense.
Cool air is more dense than warm air. So cool air falls through the warm air. Why are boilers placed beneath hot water tanks in people's homes?
Hot water rises.
Yes, water rises, correct. Hot water rises, so when the boiler heats the water, hot water rises, the tank is filled with hot water. We need something like safety. Why are houses painted white in hot countries?
To reflect heat.
Reflect the heat.
Same like almost here, old building. Which of the following is not a method of heat transfer?
Insulation B.
Insulation.
B.
Insulation.
Transmission of heat by molecular collision is
B. Convection.
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 conduction.
Conduction.
Conduction. It is a tricky question, this one, but the exact answer is conduction.
Molecular. Okay.
Just here, make it like summarize. Heat can be transferred from place to another by conduction in solid, convection in fluid, radiation in space. This comparison between the three. What is the factor affect the rate of heat transfer?
Just back.
What is this?
Just to back this, you show that three differences between convection.
This one?
Yes.
Just read it. There's different, some different information.
Oh, okay.
Conduction, convection, radiation, and some information what is different between these three.
Okay.
What is factors here affect? First one is temperature difference across the material. Correct? According to the two different temperature, it depends on the heat transfer. What else?
The medium that transfer through.
Medium?
Yeah, I mean yes, the medium. I mean
What's the medium? It means the material, for example?
yes, the median or like,
Conductivity.
Material, same conductivity. Yes. What else?
area.
Area, great. Area increase, normally heat transfer increase. What else?
So
Thickness.
here, say thickness.
Thickness of the material. Thickness of the material. So normally difference temperature, thickness, and area. Okay. Here, as you see, the first equation related to heat transfer rate for conduction. Q by T, it is Q dot. Q dot, it refers to heat transfer rate. Heat transfer rate. Q alone, it is not mentioned by heat transfer rate. Q, it is heat, which is referred to heat in thermodynamics, first law of thermodynamics. But here, Q by T is rate of heat. Okay, equal what? Minus K A delta T by X. This equation related to conduction equation. Conduction. K is thermal conductivity, A is area, delta T is difference temperature, X is thickness.
Thickness.
Okay.
Dirty.
And important thing here, this important thing, actually, last point here. Delta T by X is called temperature gradient. Very important, please. You remember viscosity?
Yeah. Yes.
What is this? Velocity gradient. Here this is similar.
Temperature gradient.
This one is what? Temperature gradient. Delta T by X. Okay? Be careful, please. And this all the time is negative. This is the reason to put negative here for the equation, to make equivalent at the end to obtain positive. Convection, it is heat transfer between two bodies according to temperature difference, but according to these two temperature difference, the flow is movement according to some part is hot, some part is cold, and then going movement according to hot fluid is raised and cold fluid is thin, and then movement to create convection heat transfer. And heat convection equation, heat convection equation, Q dot equal H, which is convection coefficient, A area, delta T. What is A area? Delta T, what is it? Delta T is a change of temperature between the surface of one body and the other body. This, for example, Ts minus T infinity, it means the surface of the liquid, for example, and T infinity for the gas above. Okay, something like this. For example, we have flow like this, and this T surface, and the flow of air here, this air, this T is T infinity. Sorry. T is T what? T infinity. Okay. So the equation here, Q dot, delta Q by delta T is Q dot all the time, Q dot. And the unit is what? Unit of power, watt. Unit of what? Unit of power, watt.
Joule per second.
Okay. If I going back to describe this one, this something like this. Body here. And this temperature, for example, T1, and this temperature T2, and you have a different temperature to can flow moving by Q dot. Okay. This thickness X, delta T here, this K for the material semiconductivity, and area is the surface area here. Okay, this is the back side here. Okay, this is the area. Okay, here this is H. Convection coefficient, convection coefficient. For last one, heat transfer by radiation, Q dot equal A, which is area, epsilon emissivity, and for black body is equal to what? 1. If the problem coming and mention is the black body, that's it, and they don't give an emissivity, you can put emissivity equal to what?
1.
Equal to 1. Sigma is Stephen constant. Stephen constant. This constant is 5.67 times 10 to the power negative 8. 5.67 times 10 to the power negative 8. This 5, easy to save it. 5, 6, 7, 8. 5, 6, 7, 8. Okay. Temperature T to power 4. T to power 4. Be careful. This temperature must be
Kelvin.
Kelvin. For the previous, no problem, because delta T, Kelvin, Celsius, it's not a problem. Okay, this one also the same, delta T. I tell you something very, very important coming in the question a lot. We have two ways to describe Q dot, which is unit is watt. Okay, this heat transfer rate. And sometimes he mentioned force, Q, whatever the symbol like dash, double dash, anything, but the name is important for me. It is heat flux. Heat
By
flux.
area.
What is this heat flux? This
By
what?
area divided by area.
By area.
area. This is very important and coming a lot. Okay. In this case, because you're going to the problem and you don't found any information, for example, for radiation, no information for area, emissivity, he tell you is black body, which is 1. This one is constant, not given. Just we found in the whole problem, 1 given temperature. That's it.